Hello students, welcome to Young Cubs. Children, by the time we all grow up and arrive to the 7th and 8th grade, we realize that science is divided into three subjects. One is physics, which deals with measurements and instruments. Second is biology, which deals with living organisms and living things. And then that is further divided into botany and zoology. Botany for plants, zoology for animals. And the third one is chemistry, which is all about chemicals and reactions that take place at a very minute level. And to that level where we go right into the depth of atoms and molecules and elements and compounds and mixtures, that minute level. So all in all, it deals with a lot of materials that we deal with in day-to-day life. So today we will revisit the minutest level of materials, which is an atom, thereby segueing to how they form elements, furthermore to their arrangements and the periodic table, and lot more. So let's begin with the structure of an atom. Children, when we talk about the structure of an atom, it was not made one fine day. It was not established one fine day. Somebody got a dream and something happened. No, it was a series of work done by a lot of scientists who delved deep. You in the last term, in the last year, in fact, you must have gone through Rutherford's study, Neil Bohr's study, and a lot of scientists have the plum pudding model of J.J. Thomson. You've done a lot of about all that. How an atom's structure was finally revealed. So, if you want to know about the stepwise, process or progress of the structure of an atom, you can go through my lectures for the 7th grade. Okay, and so right now let's look at the final structure of an atom. So, an atom basically has a core or a center, which is called the nucleus. Okay, let me put it in another color. So our nucleus, basically the center core. Okay, in this center are the two subatomic particles. Okay, one were the neutrons, which had no charge at all. Okay, neutral. They are just there, adding some mass to the atom. So they were neutrally charged neutrons. Okay, and then we had another set of particles, okay, of which the core or the center or the nucleus of the atom was made, and this were the positively charged protons. So let me write it that way. So these were positively very bad with short forms. Positively charged protons, where were they placed? In the center, in the core, or in the nucleus. Okay, and neutrally charged or no charge neutrons. Fair enough. So these were particles in the nucleus, and they were maximally placed in the center or in the core. Okay, together these two were called or are called nucleons spelling. Nucleons. Okay? Together, the neutrons and protons are called nucleons. So children, what happens when there are no charged particles, okay, in a particular room, and there are positively charged particles in the same room? So the room overall, or the nucleus overall, what charge will it consist? It will consist of a positive charge. The nucleus will be positively charged. Correct? So any atom, any nucleus of an atom is positively charged because of the protons. Okay? Children, did you know, however, an atom is atom's overall charge is neutral. The overall charge of any atom is neutral. How come the nucleus is positively charged and overall charge of an atom is neutral? That's because of the electrons. So we have electrons. And where are these electrons? They are revolving around the nucleus in orbits. So these are the orbits known as shells. Okay, they are revolving around the center or the nucleus of an atom, similar to our planets in the solar system. All right, children. Children, these orbits are known as shells. The first shell is your K shell. The second shell, L. Third one, K, L, M. Fourth one, N, and so on. Depends on how large or how big the atom is. Okay, so we have electrons. Now these electrons I will mark, or I will show like an X. Okay, revolving on their shells around the nucleus. Now these electrons are negatively charged particles. Hope this much is clear. So basically, your neutrons, protons, and electrons constitute an atom or make up an atom. So these three particles, namely neutrons, protons, and electrons, are known as subatomic particles. All right, children. Hope this much is clear. So neutrons, protons, and electrons are called as subatomic particles of an atom. Okay, coming back to the statement that an atom is always neutral. It has no charge. So that simply means number of protons is equal to the number of electrons. Correct? So if I have 10 protons, okay, if the atom has a plus 10 charge or a nucleus has a plus 10 charge, that means there should be minus 10, so that, okay, has to be minus 10. Let me not put it that way. Okay, protons, they nullify, the charges are nullified, and the overall charge of an atom is 0, or an atom is neutral. Understood this much, children? Hope this much is clear. Okay, now coming to the next bit. How many electrons are placed in each shell? Okay. So, here we have an atom. Okay. Now, I'm only going to draw the center, which is the nucleus. I'm not going to draw the protons and neutrons. All I'm going to draw is the center, which is the nucleus, and then I'll draw the first shell, which is your K shell. Okay, the K shell will always have not more than 2 electrons. What does not more than mean? It simply means that if there is the first shell, it can have either 1 electron or 2 electrons placed in it or placed on it, right? If there is a third one, if there is a third electron, if the atom has 3 protons and 3 neutrons, automatically it will have another shell around it to place the third one. The third one will not be placed in the first shell. Okay, so once a shell, so there's basically a count, okay, of how many electrons can be placed in each shell. So the K shell will always have not more than 2. Let me write it as not more than 2. The L shell will have not more than 8. M shell, if it is not the last shell, if it is not the last outermost shell of the atom, then it will have not more than 18 electrons. Now you will think, ma'am, do we have to remember it? What if an atom has more than 5 shells? So for 5 shells of each type of an atom, we'll have to remember. Remember, children, the world is not made up of only one type of material. The world is made up of different materials, different elements. Yes, so different elements means different types of atoms, and each atom of each element or each material, how many will we remember? So there was a formula being devised, and the formula, or not formula, but then an expression being devised. So it is 2n square, where n is equal to the number of the shell. Yes, that's the formula to it. So now, let me work this out. So let me work it out for K shell. Okay, so K shell is this is the K shell. It is the first shell. By the first shell, it is closest to the nucleus. So going by the formula, 2 into the first shell. So the number of the shell. So it's the first shell square. 2 into 1 square is 1. So 2. So number of electrons that can be placed in K shell will be not more than 2. So this is basically telling you this formula will basically tell you the capacity of each shell if it is not the outermost shell. If it is not the outermost shell. If it's an outermost shell, children, the number will always be 8. Outermost shell, also called as the valence shell, will always be equal to 8. 8 electrons in the shell. Coming back to working on my formula. So let's work it out for L shell. Going by the formula 2n squared, 2. The number of L shell is the second. It's the second shell from the nucleus. So 2 into 4, 8. That's why I said K shell not more than 2 electrons. L shell not more than 8 electrons. Let's find out for M shell. M shell 2. M shell is the third shell. To 9, 18, not more than 18. That's the maximum capacity of a shell. Alright, children. Hope this much is clear. Apparently, children, Mother Nature is not as mysterious as we think. If we try to decode what it is trying to say or how it is trying to arrange itself in the universe, you will realize it is quite a lot of fun. So, again, I'm just drawing the core or the nucleus. Okay. Now, we just stated that the nucleus has the positively charged protons and the neutrally charged neutrons. So, the nucleus is the heaviest part of the atom. Yes, we also spoke about the number of protons is equal to the number of electrons, and hence an atom is neutrally charged. Now, okay, let's understand this. If an atom has only one proton, okay, then obviously it will have only one electron. Yes, so here's my first shell, crooked shell. Here's my first shell. It will have only one electron, right? So, okay, this is one thing. If I have, and it is that way, children, that there is an electron, there is an atom which has only one electron or one proton. There is another atom which has only two protons, a third one which is just three. So apparently scientists have been able to discover around 118 elements. That means they have discovered atoms that have maximum of 118 protons, right? So that's how they have the atom, one atom has been differentiated from the other atom. So atom with one electron or one proton is named as hydrogen. Okay, if an atom has 2 electrons, it is named as helium. If an atom has 3 electrons or 3 protons, it is named as lithium. Like that. So that's how I'm saying, that's why I made the statement that it's very interesting to unfold the secret of nature. Okay, so now coming back to, so the proton and the neutron. So the proton and the neutron together known as nucleon, okay, consist the maximum amount of mass in the core. They make up the mass of an atom. Hence, the proton plus the neutron, the number of protons and the number of neutrons, when we add it up, they make up the mass. Hence, it is known, they are termed as atomic, what is my spelling doing here? Atomic mass number. It is denoted by the letter A. If I only have to check for the number of protons in an atom, that is known as the atomic number. Okay, why do we call it as the atomic number? Because one proton, another shell, another atom. Two protons or two electrons, another. So it is giving me the number. It is actually giving me, and that's how you will realize when I explain further. They are placed in our periodic table. Number of they kind of decide upon the roll numbers. It's kind of the roll numbers. Roll number 1, that means 1 proton. Okay, roll number 2, 2 protons, and that's how they're lined up in the periodic table. Okay, so the number of protons tells you or is termed as atomic number, which is denoted by the letter Z. So now, children, if I know the number of protons, okay, and if I know the mass, okay, which is proton plus neutron, will I be able to deduce or will I be able to find out the number of neutrons in the cell? Not in the cell, in the atom. So basically, if I want to find out the number of neutrons, okay, if I want to basically find out the number of neutrons in an atom, all I need to do is A minus Z, the total mass minus the protons. Easy. Why would I want to do that? I would want to do that because the number of neutrons decide upon the variety available in that particular atom as well. So, let me take the example of hydrogen. If A is equal to N plus Z, A is the atomic mass number, N stands for the number of neutrons, and Z stands for the number of protons. Okay, if my atomic mass number is 1 and my protons that I have in hydrogen is 1, I know that my number of neutrons is 0. If my atomic number is 1, no, if my atomic number is 2, okay, my neutrons, I don't know, and my protons is 1, okay, that means I have how many neutrons in this? I have 1 neutron. So my neutron number has changed, but my protons, this bit, is the same. Remember, my number of protons or my atomic number tells me my place in the periodic table, and not only that, it decides what kind of an atom it is. Yes, 1 proton or 1 electron is hydrogen, 2 electrons is helium, 3 electrons. So this one, looking at this example, children, okay, my number of electrons are the same in both the cases. However, my number of neutrons have changed. So this atom, however, will yet be known as hydrogen because their names are dependent on the atomic number. My mass has changed because my number of neutrons have changed. So that means in one kind of an atom, I yet have another different varieties of it. And these varieties in the same atom are known as isotopes. So, different number of neutrons in but the same number of protons are known as isotopes of that atom. Yes, children, are known as isotopes of that atom. Let me rephrase it. If the number of protons remain the same, however, the mass keeps changing, the atomic mass is changing. Okay, so that means those are the isotopes of that particular atom. So hydrogen basically may sometimes have an atomic mass number of 1. May have an atomic mass number of 1. Sometimes it may have an atomic mass number of 2. Sometimes an atomic mass number of 3. However, the number of protons, let me write it as Z, the number of protons in each of them remains 1 only. So atomic number hasn't changed, but atomic mass number has changed. So all these are nothing but isotopes of hydrogen. Hope I'm able to understand. Hope you are clear with the concept of isotope. Isotope is nothing but a variety of different hydrogen atoms on the basis of atomic mass number, as their number of neutrons are different, but their number of protons are the same. All right, children. So we have atoms with different. There are some atoms, some atoms that have different number of neutrons. Hence, their mass, overall number of particles in their nucleus increases or decreases accordingly. All right, children. Do we understand an atom? Do we understand the subatomic particles? Do we understand that the fact that there is a mass in each and every atom? Do we understand that the subatomic particles can vary as per different atoms and as per in the same atom as well? So right now I have explained the structure of an atom and their isotopes as well. Now, coming to atomic number and the different types of atoms. So children, you see these circles right all over the page. Okay, I've drawn these circles only to depict that this is the nucleus of an atom. So, when an atom has only one electron, remember, one electron means one proton. So, when an atom has only one proton or one electron, that atom is called hydrogen. Symbol H. When an atom has 2 electrons. That atom has been given a name called helium, symbol He. Now, as we studied, the first shell cannot carry more than 2 electrons. That means it has attained its duplet state. Okay, when the electronic shell, okay, is filled with the maximum capacity it can hold. Okay, if it is 2, that's the maximum capacity, you will say that it has attained its duplet state. Spelling of duplet, D-U-P-L-E-T. Okay, the third one, where it has 1, 2, and now the third, it has 3 electrons. Remember, it's the second one has attained its duplet state, so automatically for the third one there will be another shell that will appear, the L shell. Now this atom has 3 electrons and has been given the name of lithium. Okay, lithium Li. Okay, fourth one. So this is your first, second, third, and the fourth one. So first shell, 2 electrons. Second one has a capacity of 8 children. Calculate with the formula 2n square. So this fourth one has been termed as beryllium. Beryllium, symbol Be. The fifth one will have fifth. So are you understanding the atomic number, the number of the atom? First one, 2. Second one has 1, 2, 3. Is it not visible? I hope it is. I'll take another color for this one. So first one has 2. Second shell has 2 and 1. 3. Total 5. So number of protons, number of electrons will be the same, so that the overall charge of an atom is neutral. Fourth one, I'll continue with the same number. Children, now I won't draw the first shell, the K shell, simply because we know it has 2. I'll just draw, or okay, I will draw. So 2 in the first. So we are doing the first, second, third, fourth, fifth. Oh, I did not name the fifth one. The fifth one name is boron, and the symbol is B. The sixth one, 2 inside. So 2 plus 4, 6. So sixth atom. Okay, the name is our favorite carbon. Yes. And the symbol is C. Okay, seventh one. Okay, so 4, 5, 6, 7. Okay, remember children, these electrons are always revolving around the nucleus at a very high speed. It is nitrogen, symbol N. Next one. So this one was 1, 2, 3, 4, 5, 6, 7, 8. Now the eighth one. So 4, 5, 6, 7, 8. Alright, so this one is oxygen. In Hindi, it is called as pran vayu. Pran dene wala vayu. Okay. The ninth one is, so 4, 5, 6, 7, 8, 9. So this one is FluorIne. FluorIne. Symbol F. And the 10th one is two, 4, 5, 6, 7, 8, 9, 10. Children, both the shells are at their fullest capacity. So basically, when the shell attains its full capacity, only then a new shell will appear. So over here, if you see the outermost shell or the second shell, the capacity is 8 electrons. Okay, this atom called neon, symbol Ne, is at its full capacity, which is 8 electrons in its outer shell, and that's why we can say that it has attained its octet, OCTED, octet state. Alright, children, hope this much is clear. For homework, children, I would request you to kindly draw these atoms. I have drawn till 10. You should be drawing the first 20 of them. Once you do that, further concepts will be quite easy to understand. This brings me to another concept known as electronic configuration. Electronic configuration is nothing but the number of electrons placed in each shell. So let's look at hydrogen. What I'm going to do is I'll make a quick table. I'm sure it's going to be a little untidy, but I'll try my little best. So our first, let me write atomic number. Let me write the short form. Atomic number is Z. Let me write, my next column should be element. When a material is made up of the same type of atoms, that material will be known as an element. Okay, we'll now write symbol of that element, and then we will write the EC. EC is electronic configuration. Okay. Why am I doing this? So that if I have to add in more elements, it's easy. So atomic number 1, which element? Hydrogen. Hydrogen has a symbol of H, and its electronic configuration is 1 atom in the shell. Okay. Second in place is helium. Symbol He has 2 atoms or 2 electrons in its shell. Okay. Third one, beryllium, Be 2. See, it's 3. How is this 3 divided? As 2 in the first shell and 1 in the next shell, which is the L shell. 4, boron, B. So it's 2 and 2. 5, 6 carbon. No, am I going wrong? Oh, I missed out. Oh, sorry, children. So the third one is lithium. Lithium is Li and the electronic configuration is 2 and 1. Then comes beryllium, symbol Be. It is 2 and 2. Boron, B, it's going to be 2 and 3. Remember, this second number will not go more than 8. Yes, because the second shell has the capacity of not more than 8. Yes, the first number tells you the number of electrons in the first shell. The second one will tell you the number of electrons in the second shell, but not more than 8 because its maximum capacity is 8. The sixth one is carbon, C, 2 and 4. Seventh one, and write the seventh one on the other side. So it's Z element, symbol, and electronic configuration. So we are at the seventh one. N, nitrogen. Seventh one, symbol N, electronic configuration 2 and 5. 2 plus 5 make this 7. Eighth one, oxygen, O, 2 and, it's not visible, children. This is 2 and 5. This is 2 and 6. Ninth one, fluorine, fluorine, symbol F, 2 and 7. And the 10th one, neon, symbol Ne, 2 and 8. And then you may have the 11th atom, 12th. So this is how you will learn the first 20 elements. I will teach you how to learn them. Hope this much is clear, children. So I think that's all for today. Lots of learning for today. Thank you and God bless you all.